problem number 13. We're starting with the plane flying away from the radar dish. It's currently 10 miles away from the radar dish on the diagonal. It was flying at an elevation of 7 miles above. And now the question is, what is the speed of the airplane at this moment as it's 10 miles away? I'm going to need a variable. And this variable is going to be this distance right there. And I'm going to call it
C.
C for Charlie, sure. Alright? Now I need, if I'm going to find out how fast C is changing, I'm going to need an equation that tells me about C and its relationship to other things in this problem. I'm guessing, because it's a right triangle, we'll use the Pythagorean theorem. I think it's going to be 7 squared plus C squared is equal to S squared. Okay, and here's the danger. You don't want to put 10 in there, because we're only talking about it being 10 for an instant. The value of S is constantly changing as the plane flies. Well, this is our starting spot. Remember, our general attack for these problems is create an equation, take the derivative of the equation, then plug and chug. So let's take the derivative of this equation. The derivative with respect to t of 7 squared, 0. The derivative of c squared, 2c dc dt. And then the derivative of s squared, 2s ds dt. And we can divide both sides by 2 and get rid of those. So, plug and chug time. I know what s is at the instant that I'm interested. It's 10 miles. I know what ds dt is at the instant that I'm interested in. It's 300 miles per hour. And the question is, how fast is it flying? I'm interested in what dc dt is. The question is, what's c? Okay, to find c, I'm going to have to go back to this equation and say 49 plus c squared is equal to 100, or c squared is equal to 51, or c officially is plus or minus 51, but we're only interested in the square root of 51, but we're only interested in the positive value. So how about the square root of 51 times dc dt? Or dc dt is equal to 3,000 divided by the square root of 51. And that is approximately,
420.084.
one more time?
420.084.
And of course, units please. Miles per hour.